Hello and welcome to topic 2.4 of geometry. We're going to do some more theorems and some more proofs. So, new theorems. We're just going to list them off here. If two angles are both right angles, then they are congruent. All right angles in the universe are congruent. All of them. If two angles are supplementary to the same angle, so it'd be like this: if the blue angle is supplementary to the green angle, and the green angle is supplementary to this red angle, so if these add up to 180 and these add up to 180, then these two are the same. They're congruent. When in doubt in geometry, put congruent. If two angles are complements to the same angle, this is the same exact one. The only difference is supplementary and complementary to the same angle. Then the two angles are congruent for the same reasons. If angles are vertical, then they are congruent. Right? Vertical angles will always be congruent. We proved that one last class, actually. That was a formal proof we did for that one. And the linear pairs are supplementary. So these two are big ones. They have their own names. That's called the vertical angle theorem. That's called the linear pair theorem, which says vertical angles imply congruent and linear pair implies supplementary, or adding up to 180. I should be formal here and put supplementary. So these two, definitely keep those in your head. Those are good tools to have. Next, if the non-common sides of two angles form a right angle, then the angles are, if the non-common side of two angles form a right angle, so that would look like this. You got this green angle, you got this red angle, and the non-common side, this is the common side, so the non-common sides make a right angle. Now we would say that these two angles have to be complementary. Notice that I'm drawing pictures to help me make sense of these words. And that's something that you can do for yourself as well. Because there's many ways to communicate mathematics verbally, in pictures, in charts and tables, in diagrams, and going from, say, words to a picture is sometimes hard. So drawing a picture can help. If lines are perpendicular, then they intersect to form four right angles. If you've got perpendicular lines, not only is this a right angle, but so is this one, and so is this one, and so is this one. So if you've got one right angle, you've got four, actually. Next, if lines are perpendicular, then they form congruent adjacent angle. That's the only way where you're going to have two angles that are next to each other that will be congruent. Congruent adjacent angles. If two angles are congruent and supplementary, so if they're the same and they add up to 180, the only way for that to be true is if it's 90 and 90. So 90 and 90 make supplementary, then each angle has to be a right angle. And then lastly, if two congruent angles form a linear pair, so imagine a linear pair with two congruent angles. Those angles have to be 90 and 90 again. The angles have to be right angles. So there is the list. It's the end of our theorems for now. We'll get more. So now we can use any of these theorems to do more proofs, to get more truth. Alright, so in number one here, we're going to start with the truth that DB bisects ADC. So this is the bisector. Here's your bisector right here. And I'm going to mark that as a bisector by marking that these two angles are congruent. That's what a bisector does. a bisector makes two congruent angles, or two congruent segments if you're working with segments. So we're going to use this truth and now somehow prove that this angle and this angle are the same. So we're going to start with our statements and our reasons. We'll do a 2-column proof for this one. So the first thing that always, your first statement is always the truth that you're assuming, or your given truth. So in this case, we are working with the assumption that this bisects that. So go ahead and put that in there. Ray DB bisects angle ADC. Now, if we go back in the notes to 2.2 and you look at the definition of an angle bisector, you will see that an angle bisector implies congruent angles. So now, because we're under this assumption of the bisector, we can now say that 1 and 2 have to be congruent, because that's how we define an angle bisector. So we define the angle bisector. So this is true because of this definition of angle bisector. Now, that's about as far as I go with that thought. Now I'm going to work with another thought. So if we go over here in our picture, I notice that I've got two lines that are intersecting, and they are making angle 1 and angle 3. So I'm going to go ahead and state from the picture here, because I know what vertical angles are, I'm going to state that angle 1 and angle 3 are vertical angles. And I'm going to call that given from the picture. Now, what do we know about vertical angles? Vertical angles, if angles are vertical, then they are congruent. That's the vertical angle theorem. So therefore, I can now state that 1 and 3 are not only vertical angles, but they are congruent by the vertical angle theorem. And now is where the magic happens. This is all proofs pretty much. You've got this thought and you've got this thought. And a proof is you bring two thoughts together. And so here's what's happening. Here's how you need to see this. You've got the angle 2 is congruent to angle 1. And angle 1 is congruent to angle 3. So 2 is congruent to 1, 1 is congruent to 3. 2 is congruent to 1, 1 is congruent to 3. You can skip the middleman. You can make it like a train of thought here, where now we can say 2 is congruent to 3. And that's called the transitive property, when you put things together like that with a train of thought. So there we did it. That which was to be proved ends up being our last line of our proof. That will always happen. Let's do some more. Next, we have ourselves that 1 and 4 make a linear pair. And in this scenario, what I'm going to do paragraph proof for this one. So instead of writing the two columns like above, every line of this turns into a sentence. So we're going to start with our given information. So as given, angle 1 and angle 4 form a linear pair. Linear pair. Feel free to abbreviate. So this would be the first row of my two-column proof. Okay. And I can write therefore angle 1 and angle 4 are supplementary by the linear pair theorem. Okay, so I use the linear pair theorem. Linear pair implies supplementary right here. If angles form a linear pair, then they are supplementary. Linear pair theorem. So I used the fact that this was a linear pair to make supplementary. Now, the measure of angle 1 plus the measure of angle 4 equals 180 degrees. Because that's what supplementary means. If I say that two angles are supplementary, then they now add up to 180 degrees by the definition of supplementary. So that'd be my next one. Also given, so now I'm going to bring in this last given. I got another given here. Also given is that the measure of angle 1 plus the measure of angle 3 equals 180. And so now is where we put these two thoughts together. Here's what we have. We have 1 plus 4 equals 180. We've got 1 and 3 equal 180. Because these two different things equal the same thing, we can now state that 1 and 4 equals 1 and 3, like that. Think of it like this: A equals B and B equals C, so therefore A equals C. You can kind of think of it like that. That's a transitive property. So therefore, by the transitive property, the measure of angle 1 plus the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 3. And using subtraction, we can take the 1 out and balance the equation by taking the 1 out. We get that the measure of angle 4 is equal to the measure of angle 3. Now I'm getting there. I'm getting close. This is pretty close to that. I'm getting there. I'm really close. Here's a quick way of writing therefore. Therefore. You can do therefore. That's the symbol for therefore. Therefore, angle 4 is congruent to angle 3 by the definition of congruent. By the definition of congruent. And lastly, angle 3 is congruent to angle 4 by the symmetric property. Remember, the symmetric property switches. We went 4 and 3, now it's 3 and 4. It just flips it around. So that was that proof. This is completely detailed. It's possible to skip some of these details, but you do need to make a logical progression from linear pair to congruent. That's the goal. We're going to skip number 3. We're not going to do segment proofs. Move on to number 4 on the back here. Alright, and this one, 2 is congruent to 3. So we're going to go and write that. Angle 2 is congruent to angle 3. And that is our given that we're working with. Now we can use that. We also have givens from the picture. Look at the picture. What's true about 1 and 2? Angle 1 and angle 2 are vertical angles. That's also true for angles 3 and 4. Angle 3 and angle 4 are vertical angles given from the picture. Now, what does vertical angles imply? Vertical angles imply, remember this, vertical angles mean congruent. So because 1 and 2 are vertical angles, we can say angle 1 is congruent to angle 2. And also I can go ahead and do this on the same line. Angle 3 is congruent to angle 4 because of the vertical angle theorem. Okay, so now here's what we got. Do we have enough info now to relate 1 to 4? To relate 1 to 4. Let's start with angle 1. What is angle 1 congruent to? 1's congruent to 2. What's angle 2 congruent to? Well, Right here it says 2 is congruent to 3. What's angle 3 congruent to? Right here it says 3 is congruent to 4. So therefore, 1 is congruent to 2, 2 is congruent to 3, 3 is congruent to 4. We can jump from 1 to 4 and be okay. That's called the transitive property. It's merging these thoughts together. So we can now say that angle 1 is congruent to angle 4 by the transitive property. Now, if we were to write a paragraph proof, I'm not going to write this out, but you can. Your first sentence would be, as given, angle 2 is congruent to angle 3. From the picture, 1 and 2 are vertical angles, as well as 3 and 4 are vertical angles. That would be your next sentence. Therefore, 1 is congruent to 2 and 3 is congruent to 4 by the vertical angle theorem. So you just write exactly what I'm saying. And lastly, by the transitive property, 1 is congruent to 4. You literally write that out as your paragraph proof. Number 6. This would be like what you'd see on a quiz coming up. We're going to do fill-in-the-blank proofs for now. And then maybe in chapter 3 or maybe in quarter 2 we'll have you actually write them yourself. So for now we're going to do some fill-in-the-blanks. So we're starting with 1 and 2 are supplementary. And 1 and 3 are supplementary. Prove that 2 is congruent to 3. So really what we're doing is we are proving this right here. If two angles are supplement to the same angle, then they are congruent. That's what we're proving. We're proving one of our theorems. Alright, first thing, 1 and 2 are supplementary. 1 and 3 are supplementary. That's a given. That's our given knowledge. Now therefore, supplementary makes 180 degrees. So if I take 1 and 2 and add them together, I get 180 degrees. Definition of supplementary. By the way, you should be pausing the video and trying this on your own first. Now because those are the same, that makes these the same. Measure angle 1 and 2 is equal to 180, and 180 is equal to this. So therefore these are now equal to each other. 1 shows up on both sides of this equation, which means you can subtract it from both sides. So now we have that the measure of angle 2 is equal to the measure of angle 3. And now because the measures are equal, the angles are congruent. Here we did it. That's the definition of congruent. Okay. Number 7. I'm just going to do like a flow proof here. Okay, I'm not going to write it all out. The idea is that we're starting to make logical connections. Okay, so 5 is congruent to 6. Alright, 5 is congruent to 6, that's what we have. 5 and 4 are a linear pair. And linear pair implies supplementary. And supplementary means that 5 and 4 add up to 180. So here's the merge. The 5 can now become a 6. Like that. And therefore, 6 and 4 are supplementary. But that's how that proof would end up going. I'm concerned with your logic. Can you logically get from 5 is congruent to 6 to 6 is supplementary to 4? So that's how you work that one out. An example, this next one, we've got 4 is congruent to 7. We've got 4 is congruent to 5 because of the vertical angles. That was given. We've got 6 is congruent to 7 because of the vertical angles. Can we put them all together? Start with angle 5. Angle 5 is congruent to 4. Angle 4 is congruent to 7. Angle 7 is congruent to 6. There we have it. Transitive property. That's a very informal way I just did that proof, but it works. See you later.